Hi, today I am going to demonstrate how to work on Kicad, that is to design a PCB board. As you all know that the PCB is a printed circuit board which is an electronic board which is used to where there is no wires, it's on the board itself, so that you can get the strength for the circuit and the wires will be not damaged. So the easiest way, there are many softwares which are available to draw the PCB, but the basic software which is used is Kicad. I am using 5.1.12 version of the Kicad. There may be some other versions in your lab. So all the things which I'm demonstrating here is same for all the softwares if you understand it. So I'm going to demonstrate on this Kicad 5.1.2, this version. So first you need to create a file in your PC, that is in local disk D or in the desktop. Better you create it in local disk D. I am also creating it local disk D. I'll give the name as demo. Next, open the Kicad software. Then you'll get like this window. Then click on file, which is in the left corner. Then new, then project, and select the file which you have created it in local disk D. I have created a file as demo. So click on this and create another file, such as I'm designing a basic circuit. So I'll give the name as basic circuit. Save. Then after saving, you'll get this basic circuit dot kicad dot underscore PCB and a basic circuit dot schematic name. If you get this name, it indicates that your folder is created in your file. Then after this, click on the icon which is showing a schematic layout editor. Then you'll get a window like this with a dotted screens and a margin at a side. Then now to place the components, in the right corner you can see many icons such as select item, highlight net, place symbol, ground and wires, etc. Many symbols are there. You need to select this third one, that is like a op amp. There's a icon like a op amp, so select that and click anywhere on the dotted screen to place the component. Just left click it. If you left click, then loading symbol libraries means I have just downloaded the software, so it's showing as loading symbol libraries. After this, you need to select the circuit components which you need it. I am designing a basic circuit, therefore I am using resistor, a battery and a LED. So I am using a resistor of R. You need to type R or resistor. Better you need to type R for the resistor. So click OK. Afterwards you place it here. Place this like you click left click it, so that the icon will be placed in the dotted screen. Next, again to place the next component, just again left click it and select next component, that is battery. Then click OK. If you want to rotate the component, then just press R, or if you have already placed it and now you want to rotate it, take the mouse to the component and click R. Then next component is LED, so you need to search as LED and you need to click it and click OK, so that LED will be placed and rotate in this direction, because the negative of the LED should be connected to the battery. So likewise I have connected it like this so that I can connect this easy. The another one drawback of PCB is that you cannot merge two wires, it should be separated, so take care of that. Next, the components are placed here. Next, you need to connect the components, so you need to place the wire. The wire is available in the right corner, that is first, second, third, fourth and fifth component. Fourth I guess. Fifth component is place wire. To place wire, you need to just click on this corner and take it to this corner. So just left click it so that the wire will be placed. In all the places you need to do the same thing. Okay, the circuit is completed now. One resistor is there, one battery and the another LED is there. So the basic circuit is completed. This is just 25% of the full circuit. which is needed to design. This is just a 25%. Next you need to place a power ground and the power symbol. Just click on the not components, just click on this ground symbol. You can see that is fourth component. Click on that and click here to place the component. Type VCC. You will get a VCC power flag. Keep it here. Then again press and select the ground symbol. Place this like this. If you place it, then the circuit is a proper one. Next, this is the circuit I have designed it. Next, the procedures are in the top side. You can see that the op amp mark, another op amp mark, create, delete or edit symbols. That is not required now. This pencil mark, you can see annotate schematic symbols. Click on that annotate symbols. Annotate is nothing but it is giving names to the you can see here BT1, BT question mark, R question mark, and for the LED also you can see D question mark. So when you click on annotate and when you annotate the circuit, you will get a names to the circuit. See here, annotated VCC as power 1, annotated ground as power 2, annotated battery as BT1, annotated LED as D1, annotated R as R1. So that it's like giving names to the circuit. You can give it manually also, but annotate is the what is that general thing to do for the naming of the circuits. Next, click on ERC. ERC is nothing but electrical rules check. Electrical rules check in the sense, if the wire is broken here, then you will get an error in the ERC showing that it's an error here. So this is the useful tool ERC, which is a useful tool for seeing, checking the circuit if it's proper or what. See here you get a this what error you get, pin connected to other pins but not run. This is an error, so you need to place a junction here and then save the circuit and then again annotate it and then click ERC again. After the ERC errors, no errors are there, ERC, then you click on assign PCB footprints to schematic symbols. This is the main part of the circuit designing. This is the main part and this is the major role. You need to just concentrate on this to select the actual footprints or required footprints. You need to select it here. To select the footprints, basically you need to know how many terminals or the how many leads are there for the components. For example, resistor has 2 leads and LED also has 2 leads, transistor has 3 leads. For resistors to be placed, you need 2 holes on the PCB board. So you need to select the perfect this footprints, this loading footprint, because it's just downloaded software, newly downloaded software, so that's it's loading the footprint libraries. Now the footprints are loaded and you can see many footprints. These all footprints are not required, some of them are required here. So for the battery I use you should use here, if you click on battery, or you should use a connector. Here you can see banana jack 2-pin connector. You should use 2-pin connector itself for the battery, because battery has 2 terminals, that is positive and negative. So you have to use 2-pin terminals. You can also view the footprints, like if you click on banana jack 2-pin and click here magnifying glass, you can see the picture of this connector. You can also see 3D display. You can also see the 3D display of this banana jack 2-pin connector. You need this type of connector, so double click on that. It is the footprint is assigned for the battery as connector banana jack 2-pin. Now LED has 2 terminals, so you have to select, it's just like diode itself, so you have to select your diode, that's THT. In all the circuits you have to use only THT, not SMD. SMD is a surface mounted devices and you are not using any surface mounted devices. So select diode THT, and here many diodes you can see. Just any diode you can just any 2-pin thing you can select it, and you can just observe if LED is going to fit here or what. Just see all the things, and this is for the resistor, you can use it. resistor you can use it, diode horizontal you can use this for the resistor. And for the LED you can also use LED. Here you can get LED THT. In that LED THT use horizontal one like this, where you can mount two pins 1 and 2, where you can insert the two terminals and double click on that. Now the footprints are loaded. For the battery, banana jack 2 pin, LED horizontal, this LED THT and diode. Remember one thing, you are not going to use any SMD things footprints in this PCB lab itself, because SMD is surface mounted devices, and in the lab we are not using any surface mounted devices, we are using only this THT things. Then save this. Save the schematic here in file, and then close this one. And next is you have to generate this is over. Next you have to generate a net list. So click on net. Here you can see net, just click on that and generate net list. You need not change the name, just click save. Then next click on this generate bill of materials. Bill of materials means how many materials are required, that is computing, the system is computing that how many materials are required. Just click generate and close. No need to change anything in that. If you change, the entire circuit will be changed. Then next this run CPVCB, it's the last step. See, first you have to annotate the schematic symbols, means giving names to the symbols. Next ERC means electrical rules check, for the errors we are checking it. Then CPVCB, here we are adding the footprints to the circuit. Then generate netlist. You need not change any names here or anything, you should need not change, just save it. Edit symbol fields you need not to click, just generate bill of materials, generate, close. The last step is this run PCB new to layout printed circuit board. You click this one, then you will get a board something like screen, something like this black screen. First here you have to note is, before loading the netlist, there we generated the netlist. Here you need to load the netlist. Loading the netlist in the sense what the circuit you have drawn there, you will derive it here in this window. You are going to derive that all the components. Before deriving the components, you need to set the tracks. In the PCB board you have seen the metallic tracks, that size you should set here. To set the size, just click here board setup. Next here net classes, here track width you should make it as 1 mm. Before loading the netlist only you should make it track width 1 mm. Don't change any other things, wire size, wire drill, micro wire size, micro wire drill, clearance, default, nothing you should change here. If you change the clearance, full circuit and the full software will be corrupted, and you have to create a new software again, you have to delete it and you have to install again itself. So don't touch this clearance. Track width only you have to change it as 1 mm. Then save it. Here you select back copper b.cu, or you can also select in the right side back copper. Its back copper means only in the back side you will get a copper. Front copper is not required because we are going to solder the components at the below side. Therefore you have to use back copper. Then loading the netlist. Loading the netlist, see the procedures. Here you have to go to tools. Here load netlist, update PCB. Here you have to see select the netlist file. I'll go here basic circuit.net, open, then update PCB. Now what you have done there, it is derived here. Just left click, this circuit will be set here, and just click back copper. To move the any component, now you have to separate these components. It will be mixed either in this manner or it will be like in this manner. You have to separate the components. To separate the components, take the mouse cursor on that component. Don't click anything, right click or left click you should not click. Just take the mouse on that component, click M. Click M or right click on this, or you will get footprint BT1 on FCU. You move this component, or using the M key on the keyboard you can move this. Just keep the cursor on the component, click M, and take wherever you want the component to go. you should take care that the PCB board is very small, so you should make it compact one. So I'm placing the components nearby. Okay, I have separated or segregated the components in a small manner. Now you have to take the tracks for the conduction path. So you have to click here. You can see one, two, three, four, fifth. The fifth component is root tracks. You have to click that root tracks, and to place the wire you need to click here. You need to click here, and just click and leave, and next here you can place it and leave it. Next here you should click, and here you should leave it. Here also same thing, wherever the tracks you need, you have to put it. The white line, see here white line is there now, there only you should take it. White line you should take it the wires. Otherwise, if the full circuit is not completed, or on single wire, on single path there are two wires, the circuit will be wrong, so that you can't get the exact last image. Now after this simple circuit is ready, now you can just see here. If you click on print, then print preview, like this circuit you can see. If you see this circuit, you can't solder on this because the what drills where you are making is very small, and the contact path is also not there. So another one facility which is there is, here you can see net bt1 pad 1. It is nothing but where you can solder this. In these pads are nothing but where you can solder the components. So you should edit the pads. To edit the pads, click right click on this pad, and here properties you can see properties. And this circular hole should be 1 millimeter, because your drill bit in the lab is 1 millimeter. Therefore you have to select here as 1 millimeter. And this all nothing you can change, you should change. That's fine. Just make here 1 millimeter and click OK. For the all pads you should do like that only. Okay, these two are done. Next, for the resistors also you should do same thing, but you should see the size there, and you should make, because the two terminals should not be touched to each other. So when you do the soldering, it should not touch each other. For all the pads you should do like that only. The drill size should be 1 millimeter, because the drill bit is of 1 mm. You should take care while doing for the LED, because terminals should not be shorted to each other. If terminals are shorted, the LED will not glow. Then after this thing, save the circuit. Save the circuit, and the last thing is to preview it or to print it. You should print this circuit on the oily paper or the papers which you get on the magazine. Print, and you should not change here anything, just you should click the print. So I'm seeing the preview here. You'll get like this preview, where the two circles you can see, big circles there, you should place the battery terminals, and here the resistor, and here the LED. Then next, what the procedures are to iron, to keep the oily paper, printed oily paper on the PCB board, and then to iron it, then to put it in the copper sulfate solution, and you should keep it in the sunlight. So this is the schematic how to draw it in the Kicad software.